Hello, friends. Welcome to Science Talk. I'm your host, Jim Massa. I want to share with you another paper soon to be published in Geophysical Research Letters. It's been accepted for publication, but still has, after undergoing full peer review, but now has to go through the whole, editing, typesetting, ordering of the figures and the tables, etc., proofreading, the whole 9 yards before it gets in final form. It's just been accepted like June 15th for publication. So probably be several months before it ends up in an issue. But what are we talking about here? Satellite and ocean data reveal marked increase in Earth's heating rate. Okay. So let's see. And again, I'm reading to you from the abstract. Earth's energy imbalance, in the paper they call it EEI, is a relatively small, presently about 0.3% difference between global mean solar radiation absorbed and thermal infrared radiation emitted to space. Earth's energy imbalance is set by natural and anthropogenic climate forcings and the climate system's response to those forcings. It is also influenced by internal variations within the climate system. Most of Earth's energy imbalance warms the ocean. I just did a video. I said 93% of greenhouse gases via the result of anthropogenic activities has been absorbed by the ocean. So it's that other 7% that's done all the heating of the atmosphere, melting of the ice, thawing of the permafrost, and so forth. Look what just only 7% has done. You've got 93% lurking. That's thermal inertia. And as the ocean stratifies, that heat is going to diffuse into the atmosphere. So, as I said, most of the Earth's energy imbalance warms the ocean. The remainder heats the land, melts the ice, and warms the atmosphere, which I just said. We show that independent satellite and in situ observations each yield statistically indistinguishable decadal increases in Earth's energy imbalance from mid-2005 to mid-2019 of 0.50 plus or minus 0.47 watts per square meter per decade. And this is a 5% to 95% confidence interval. Another way of saying two-tail testing. This trend is primarily due to an increase in absorbed solar radiation associated with decreased reflection by clouds and sea ice and a decrease in outgoing long-wave radiation due to increases in trace gases and water vapor. These changes combined exceed a positive trend in outgoing long-wave radiation due to increasing global mean temperatures. The last sentence basically says more heat is being absorbed than lost. This is what's going on here. So I'll read to you the plain language summary, and then I have a few comments. Climate is determined by how much of the sun's energy the Earth absorbs and how much energy Earth sheds through emission of thermal infrared radiation. Their sum determines whether Earth heats up or cools down. Continued increases in concentrations of well-mixed greenhouse gases in the atmosphere and the long-time scale time required for the ocean, cryosphere, and land to come to thermal equilibrium with those increases result in a net gain of energy, hence warming on Earth. Most of this excess energy, about 90%, we know it's 93%, warms the ocean, with the remainder heating the land, melting snow and ice, warming the atmosphere. Here we compare satellite observations of the net radiant energy absorbed by Earth with a global array of measurements used to determine heating within the ocean, the land and atmosphere, and the melting of snow and ice. We showed that these two independent approaches yield a decadal increase in the rate of energy uptake by Earth from mid 2005 through mid 2019, which we attribute to decreased reflection of energy back into space by clouds, sea ice, increases in well mixed greenhouse gases and water vapor. Okay. When sun energy comes into, reaches the planet, it typically comes in on the UV side, what we call shortwave radiation. That comes in on the ultraviolet side. That's why they talk about screen blockers, sunscreen blockers, whatever, so that you don't get burned when you go sunbathing, what have you. Not that I do that. So that's because, and what it says, it's protection from the UV light. So the sun energy is coming in on the shortwave, on the ultraviolet end of the spectrum. It hits the surface, and the surface could be ice, open water, land, trees, animals, and now concrete and steel, whatever. So the energy comes in, it's absorbed, and whatever, not all of it is absorbed, some of it is reflected. When it reflects, it heads back out into space in the infrared side of the spectrum, the long wave, and it's called long wave radiation. So if you do a simple heat budget, you do energy in, and then what uses the energy, the very absorption by the ocean, absorption by plants, by the land, so on. And then you say, okay, so what is lost? Okay, so now you have long wave infrared reflectance back into space. Because of the Arctic Ocean, with the traditionally thick sea ice, and Antarctica, the big chunk of ice down there, they were basically serving as the refrigerator for the planet. A lot of albedo from there, reflecting a lot of that sun energy, so that the result was that either the energy there was a net loss of energy to the Earth, or it was in equilibrium. Now we're melting the Antarctic ice. We're losing chunks of that. We're losing the sea ice. We're losing Greenland. Right? We're losing the Himalayas, right? Sometimes called the third pole, the Himalayas. So we're losing all these ice, which means albedo is decreasing. So now, instead of that sun energy being reflected back into space, it's absorbed. Now we have an excess of absorbed energy, and this excess of absorbed energy is greater than the lost energy. Net in is greater than net out. You're going to heat up. That is what's happening. That is basically what they're saying. But they actually have been quantifying this. And you can take into account the AGGI, the Annual Greenhouse Gas Index. We see that, for example, when compared to the 1990 baseline based on the Kyoto Protocol being agreed to, when you look at the values for 2020, 30 years later, there is a 47% increase in how much energy measured in watts per square meter has occurred on the surface. That is a significant amount. And suspicion is that just like the temperature increases are exponentiating, just like the permafrost thaws are exponentiating, just like the ice loss is exponentiating, so is the heat absorption will be exponentiating, which makes sense that the temperature increase will also be exponentiating. But we can, as opposed to just measuring the temperature, we can actually measure the energy. And that helps us create energy models more efficiently. That gives us better projections as to what will be likely to happen in the future. So this is a very interesting, abstract. All we have right now is the abstract. The paper will come out presumably in several months, and hopefully I'll be able to catch up with it then and share that with you in a little further detail. But keep in mind, energy absorption is now exceeding energy loss, and we're heating up. and we're heating up quite rapidly, and it's accelerating. Thank you for your time. Hello, folks. This is Jim here with Science Talk, asking you to please subscribe to my channel and to inform others of my channel and of the work that I do. Please share to social media platforms that you use. Also, as a reminder, don't forget to click the bell so that you know when I load up more videos. Finally, I ask that you support the work that I do by becoming a patron at patreon.com. Details in the description box below. Thank you for your support.